Hi everybody. I wanted to make a video to help teachers who have relatively little experience putting equations and scientific types of quantities into Microsoft PowerPoint in a way that they can manipulate it, learn to do so. This is especially important right now because a lot of teachers are moving to distance learning with the outbreak of coronavirus. So I'm going to do this both in Microsoft Word and then Microsoft PowerPoint. It actually works exactly the same in both tools nowadays, assuming that you're using a reasonably recent version of Office, I believe starting from about Office 2010 and later. You could do this in both Word and PowerPoint. So let's just start off with Word. And I make a blank document. How do I write an equation in this blank document? In the old Microsoft Word versions, you had something called MathType, which was a program that people kind of got used to using it because of muscle memory, but it was not all that intuitive in terms of typing. The newer version of Equation Editor in Microsoft Word is much better. So the way you get into that is just whenever you want to write an equation, whenever you want to write an equation like this, space, I press Alt equal. The Alt equal gets me into Equation Editor. So Alt equal, now I'm in Equation Editor. So a reasonably common equation in physics, for example, is F equals ma. And I'm done writing that equation. So now I can press Alt equal and get out of Equation Editor and just keep typing, or like this, a common math equation, y equals mx plus b. Notice that by default, all of the quantities are italicized. That is something that is the norm in both science and mathematics, that physical quantities, coordinates, etc. are italicized when they are typed out. So, fine. I've written my equations. So let's say I want to write something a little bit more complicated. First, I'm going to get rid of this. So I'm going to do a Control A to highlight, backspace gets rid of it, and now Alt equals gets back into Equation Editor. How about the most famous equation of all time? E equals mc squared. Well, how do I do that squared? Well, in the old versions, it was kind of difficult. You had to click around to get exponent keys and all that. But now you can just write caret 2, and once you press space, it automatically prettifies it for you. What if I have quantities that I want to plug into this equation? Well, remember, quantities, the variables for quantities are italicized, so what if I have a mass of 2.0 kilograms? Well, if you just wrote out kilograms, well, that seems kind of like a quantity. The norm in science and math is that units are never italicized. So you can kind of go backspace and you can do Control I to change the italics back to non-italics and do kilograms. Now do Control I again to get back into italicized. Or if you didn't like that, after doing 2.0 kilograms, you could do quote kilograms, close quotes, and upon pressing space, it takes out the italics. That's often been a useful trick for me if I want to put in text. So the speed of light is c equals about 3 times 10 to the 8 meters per second. Well, how do I do times? Well, I could do the asterisk star, but we have a better way in Equation Editor. We can do a bullet, like the dot. So to do that, you can do backslash dot, but that gives you an exponent, dot. So in this case, we do backslash bullet, and that gives you a normal bullet. Unfortunately, I had a space left in there, so go that times 10 to the 8th space. If I did not do the space and I did meters per second, so I'm going to undo the italics and do meters per second. If I didn't do the space, watch what happens. Uh-oh, I didn't want that. So instead, I do a space, and now my units, meters per second, and now I have it like that. What if I didn't want the bullet? What if I wanted a normal times? Well, in that case, you do just backslash, surprise, surprise, times, space, and now it gives you the normal, nice times sign in the middle of the margin for the writing. Times 10, caret 8, space, italics, meters per second. And now I can actually go, therefore, how did I do that? Well, I did minus, and then the greater than sign, boom, that automatically makes it an arrow. Therefore, E equals 2.0 kilograms, unitalicized, close parentheses, space, and that actually, if there is something big there, the parentheses will correct, times 3.00 times 10 caret 8 space meters per second space close parentheses space caret 2 squared. Notice how the parentheses ended up getting nice and big because I had those units in there. Well, let's see. 3 squared is 9. 10 to the 8 squared is 10 to the 16. 9 times 2 is 18, so that'll be 18 times 10 to the 16, or 1.8 times 10 caret 17 space. Well, we know energy units. Those are joules. So unitalicize, capital J, and we're done. What if I wanted to do fancier stuff? For example, infinity signs, or even better, those of you dealing with calculus stuff, limits. So how about we can do, I've gone into my equation editor and I see a bunch of tools up here. I can do limits. For example, I can say the limit as down here, I can say x goes to, that's the minus sign, the plus, and then the greater than. What if I want to do infinity? Well, that'll be backslash infty. Boom. The limit as x goes to infinity of, well, how about open parentheses 1 plus. Now, watch, I can do a fraction, and the fractions follow normally. 1 over x space close parentheses space to the x. And I have that, and you probably know that that limit is actually Euler's number, the base of the natural logarithm, that e being about 2.718281828459045, 235, and how do we do etc.? Dot, dot, dot. And after doing that, it automatically spaces out the ellipses for you as well. So that's another cute little feature here. So again, that infinity sign, going into equation editor, we have backslash infty, and there's your nice infinity sign. What about Greek letters? We often deal with Greek letters, especially when we're talking about angles. Well, let's write an angle. How about we have theta? Well, that would just be backslash, type the name of the Greek letter. Theta, boom, equals, how about 37 degrees? Well, how do I do a degree symbol? Well, again, backslash degree, boom, and it's there. So we have 37 degrees there. That's a common angle. That's the angle of a 3, 4, 5 right triangle. Now, other angles, for example, we have phi, or alpha, or how about angular velocity, or angular frequency as it's sometimes called. We have omega, well, backslash omega. Well, sometimes we have other types of frequency. For example, in physics, we have precession frequency. That is capital omega. Well, I've just been doing backslash omega. Well, if I tried that, that wouldn't work. Well, what's capital omega? That's capital omega with a capital O. Boom, and there's capital omega. It works for all of the Greek letters. What about real numbers? For example, let's say you have x is an element of the real numbers. So when you have x as an element of the real numbers, we say, well, if it's an element of the real numbers, we mean that it's in the real numbers. So I do backslash in space, there's that. Now, the symbol for real numbers is this kind of thing that looks like a double R, so to speak. Oh, well, that sounds familiar. How about double R? And there it is. You can do the same type of thing, for example, if it's an element of the counting numbers, the natural numbers, that is, double N. Or if it's simply a rational number, double Q. And you have all of those types of things. Or a positive rational number, caret plus. Whoops, I forgot to shift, caret plus, and there it is right there. So all of those tools work. So we could also do the same thing in Microsoft PowerPoint. So shifting over to PowerPoint, here I have a little default template that I've opened. So equations, I'll make my title. And I can do the same thing in here. I can do Alt equal, and I get equations. And let's start with a physics equation. Power equals work over time. Notice after pressing the spacebar, it ended up working out in terms of the fraction. Now, it's important that you don't have any text on the line. For example, if I got out of this and I started typing, well, then it makes it nice and small, and it can be hard to see, especially if it's a complicated equation. So I have power equals work over time, and let's say that my work was, W equals, okay, how about 25 joules, and my time was 5.0 seconds. Well, we have power equals, well, I've done a parenthesis here. Why a parenthesis? When you're doing numerators and the denominators, you want to open a parenthesis around your whole numerator. So I have 25 joules, now I close parenthesis, divided by, open parenthesis, 5.0 seconds, close parenthesis. And now when I press space, it makes it nice and pretty. And 25 divided by 5 is, of course, 5. The units for power are watts, but in this case, I very much need a non-italicized W so that it doesn't get confused with the italicized W for the quantity of work here. So that's another reason for distinguishing between non-italicized units and italicized quantities, which is easy to do in Equation Editor. So you can also do sums. So for example, Alt equal, getting back to Equation Editor, that works in Microsoft PowerPoint as well. I can go to these sums, and I can do it either with or without indices in my sums and everything. So I can do, for example, the sum of, for example, like I equals 1 to 8 of 2 to the I. And of course that would be just 2 plus 2 squared plus 2 cubed, etc. So it works with sums as well. Now, what about for integrals? So let me get rid of all of this. So I have an integral, and let's say I want to evaluate an integral, and I want this to be a definite integral. So how about I evaluate the integral from x equals 1 to 3 of, let's say, how about 2x cubed minus x dx, and I put a space there just because I'm kind of used to doing that. Well, we know how to integrate that. That's equal to, well, raise the x to the fourth power, that's going to end up being a 1/4 x to the fourth minus x squared over 2. Well, how do I do that with those bounds? Here's the trick here. You do backslash left, and that gives you a left marker, so to speak. And now we open parentheses with our integrand. So we had an x to the fourth over 2 minus an x squared over 2, close parentheses, and now we do shift the backslash key to give that nice vertical line, because that's how we usually like to denote integrals that still need to be evaluated after at least have their bounds plugged in. And I'll do an underscore for a subscript. Starting from x equals 1, boom, space, and now caret 3. And that gives me my upper bound as well. Notice that that left brace ended up, or that left stopper, so to speak, disappeared after I did that, but that's just their way of doing that in Microsoft's Equation Editor now. And then, of course, you can just evaluate this if you want, but in any case, that's how you do it to begin with. So I found that particular thing having to do with integrals to be quite useful for me, especially in a lot of my physics classes where I'm dealing with integrals with equations as well. And you can also do more complex integrals. For example, we can do Gauss's law in physics. We have integral of E vector dot bullet, d A vector equals the enclosed charge over this quantity epsilon naught backslash epsilon underscore 0, boom, and now I have my subscript there as well, and it ends up being nice and pretty. Now, what if I want to do animations with this? So let's say I am going back to evaluate this integral. So I'm going to put the first evaluation on the next line. Or even better, we can go down and say example. Whoops. Let's get out of this math type. Well, it's giving me the math font, which I don't like. So I'm just going to go back to my Calibri and not italicize it. So example, colon, evaluate the integral, the one that I have here, which I'm just going to copy and Control-C and Control-V, like that. But that's not very pretty. So I'm going to do evaluate the following integral. And at the beginning here, enter. That puts it in the middle of the line. And now we have solution. So we have the integral. Move this back to the previous line. And now we'll say equals, that's going to be an x to the fourth, well, that's 3 to the fourth over 2, minus 3 squared over 2, minus 1 to the fourth over 2, minus 1 squared over 2, equals 3 to the fourth is 81. And that actually would just have a common factor of 1/2 right here, so we can actually just pull that out right here. So we have 81 minus 9, and then the 1 minus 1 in here cancels, so we just have a minus 0. So that's going to be 72 over 2, which is 36. What if I want to do some animations here? So I'm going to make some more space here because I want some of this type to be a little bit bigger, like that. There we go. As you make your bounds bigger, the type ends up adjusting. If you don't like that, you can double-click on things and change the font size. So in this case, though, one of the things that I don't like is that there's not much space between this lower integral bound and my evaluation here. So here's what I'm going to do. I'm going to highlight this and go to paragraph and change the spacing of that particular line, change it to multiple, and I'm going to make it like 1.2 lines. So now, not only did that get it on the same line because of the fact that there's more spacing here, so it automatically shrank the text on the overflow, but it gave me the extra space that I want here. So let's actually animate this. So let's say I want to start off with this thing, so I triple click this to get the entire line, click on animations, and now I'm going to say, okay, I want to maybe either make this fade or float in. I'm going to make this fly in. So, boom. What if I want this to come right after? So I want it to come from left to right, so I'm going to do wipe. So wipe makes it come from bottom to top, but I can change that and make it go from left to right. And that came a little too quickly for my taste. So what I'm going to do is I'm going to click on this animation pane here, and I'm going to extend that time outward to 1 second instead of ½ second. And also, I want this to come right after this. I don't want to have to click for this to happen. So I click here, and instead of starting on the click, I start after this comes. You'll see what all that means once we go through the example, once we're done with the slide. So there's the example. So how about the solution? I'm going to have this fade in, and I'm going to have this, I'm actually just going to, well, how about we have acute animation here. We're going to add more entrance effects, and they have additional options here. So in this case, I'm going to have this whip in, which means that here it was a slow case, but when we actually animate it, it's going to be faster. And I can hover over here to see how long all of this takes. Each character takes half a second to come in. The whole thing takes 3 seconds. Let's say I want to change that to about 0.4 seconds to come in, and now the whole thing ended up shrinking. That's fine. If I still didn't like that, I could shrink this down to about 2 seconds. So we've evaluated our integral. I triple click on this whole line, and in this case I'm going to add a different animation, and I'm going to have these characters flip in like so. I'm going to hover over here, click on this area on the border right here, and take this down to half a second each, and also make this down to 2 seconds also. Well, where's my answer? The answer is 36, but you know, good form is often wanting to put boxes around answers. So I actually already created a default box at some other point, such that whenever I click on this particular icon, it comes in with a yellow filling and a red border. But if you don't like that, you can right-click on it and do Format Shape, and you can change the fill, the color of the solid fill. You can also change the color of the border line. In this case, it's red, or you can make it no line at all. So in this case, I want this to come after my numbers have been animated here, and I want it to just suddenly appear. I don't want it to appear instantly after. I don't want to have it click either, so I'm going to click after, but now I'm going to click on this and drag it a couple of tenths of a second so that it comes a little bit after. Also, I don't want it to hide my answer, so I'm going to do a right click and send to back. So now it's transparent for the number itself. You can also get rid of your animations. For example, you can have things animate out. For example, let's say that I'm done with this, and I can add an animation to this, click here, but I want it to be an exit effect. So maybe I want it to spin its way out like that, and maybe evaluate the integral with different numbers and change the bounds, so to speak. So that's how we can do that. Let's see how it actually looks. So slideshow from current slide. So we click the right arrow key. Whoop, it flew in, and then we got our example. And now we want our solution. We've gotten the whipping motion of the variables and the numbers. And now we have the flipping motion of the numbers, and we got our box around the answer. So I want to escape out of this, and maybe I want to make a new slide. So let's say that I want to teach chemistry, and we're talking about radioactive decay. So let's say we have something like an alpha decay reaction. Well, that would be a nice example of that is a uranium-238 nucleus decaying into a thorium-234 nucleus plus an alpha particle. So how do I do a uranium-238 nucleus? In this case, I'm going to go and I want scripts here. And in particular, I want this type of situation where I have scripts on the left side. So uranium has the symbol U. It's a uranium-238 nucleus as opposed to a 235 nucleus. Uranium's atomic number is 92. And I just clicked the right arrow key a number of times so that I get to the end of this. And it's going to undergo an alpha decay into a thorium-234 nucleus. So I do the same thing. I could have also copied and pasted this if it made things a little bit faster, but in this case, so thorium is 90, it's TH. And plus an alpha particle. I could just do \alpha, but another way of writing an alpha particle is a helium-4 nucleus. So that would be a script with helium-4. And going back here, we have the atomic number of helium, which is 2. With elements, the convention is generally to not italicize them. So I'm going to not italicize them. And you could also have something like a gamma decay. In this case, there isn't a gamma decay, but for example, in a proton-proton chain in the sun, we can have proton-proton chain. So after the first step of two protons combining to make a deuterium nucleus, and a deuterium nucleus combining with another proton to make a helium-3, well, here's that second step. We have a deuterium nucleus. I'm going to unitalicize things at the beginning now. So again, I have my script. So I have a 1, a 2, and deuterium. Whoop, it did not unitalicize it for me, so I'll just do that later. Plus a proton, I could just call that a P plus, or a hydrogen 1,1, yields a helium-3 nucleus. Oh, I already have something kind of like that here, so I'm just going to write this and change that to a 3. That also ends up giving you a gamma ray. How did I get to the end so quickly? I did function right on this particular keyboard. The function key for the right arrow key is end, so that just got me to the end immediately, but plus a gamma ray, so backslash gamma. So you can also get that. So that's how you can do some of these nuclear reaction types of equations in chemistry as well. What if I wanted to draw something? Like, let's say I'm in physics and I want to draw a free body diagram. So what I'm going to do in this case is I'm going to open up Microsoft Paint, which I have as one of the quick icons on my computer. And I'm going to go to brushes. First, for a free body diagram, I need to draw the particle. That's kind of a small object, hard to see. So I'm going to do a Control-Z to get rid of that and make it bigger. I clicked on the size and paint. There we go. There's my dot. And let's say that I have an object that is falling in an elevator that's accelerating downward, which means there's a gravitational force downward, but since it's accelerating downward, the normal force upward on it is not quite as big as the gravitational force downward, which is why it accelerates downward. So I'm going to bring in my arrows. I don't want it to be too big of an arrow. So there are arrow options in here. So for example, something like this. But this is not quite what I'm looking for here. It's a little too big, so I can actually make my own arrows. So I made a vertical line down. I'm going to make another, just one other line right here. And now I'm going to use symmetry. I'm going to select this, select it, Control-C for copy, Control-V for paste, and watch this. I can click on rotate and flip horizontal. Boom. And I'm going to merge it with this. But watch what happens if I do this without thinking. Whoop, it makes it disappear. Ooh, I didn't want that to happen. So I go back and do a transparent selection. And now I can merge it with this. It's not quite right with the mouse, so now I can use my arrow keys down once, left, 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 left. If I do left once more, it's too thick, but now I have it. And thing is, unfortunately, I didn't make this long enough, so I'm going to make it a little longer. Control-C, Control-V, and move this over here. Use my arrow keys to get it perfect. Now that's as long as I want it. So I do Control-C on this. Now I'm actually going to move it onto my dot. So there's my weight vector downward. And now my normal force vector upward, Control-C, Control-V. And now I want to flip this like so, but I don't want it to be as long. So I shave off part of it and press delete. And now I move it back. Boom. There we go. And now I have my free body diagram, except it's missing stuff. What's it missing? It's missing labels. I want to get rid of this stuff now. I could do those labels by writing text in here, but those aren't as pretty as the nice equation editor labels that I want. So I'm going to go back into Microsoft Word. I'm going to get rid of all this stuff, Control-A and then backspace. And now I'll get back into equation editor. Well, force of gravity is W equals mg. And normal force is usually given by lowercase n, or it's often given by lowercase n, or you could do F subscript n. And now I have this, and now I'm going to do a print screen. So on my keyboard, the print screen is just above the plus sign. I don't press any other keys. I just press the key above the plus sign that says print screen, like that. And now, well, if I pasted this in here, it would just make that disappear. So Control Z to undo that. I'm going to right-click on my paint, open up another paint, Control Paste here, and now select this over here, copy, go into my original paint, paste. This is still a transparent selection, so I move this down over to here, and I move this over to here. So now I want to paste this into my PowerPoint document. So I go into here, and let's say I don't want too much here. I'll just say elevator accelerating downward. Draw the free body diagram for a weasel that is present in the elevator. Well, let's say I want a different background here. So I right-click, Format Background, and I get rid of my animations here. I could do gradient fill with a number of different gradients here, but I actually want a picture. So I'm going to Insert, and from a File, and in particular, I want, let's say, how about something nice and colorful? Just scrolling down, I've saved a bunch of these for purposes of backgrounds. Oh, this one's nice and colorful. I'll insert this. Uh-oh, now it's hard to see my text. So what I'm going to do is I'm going to change the transparency of this, make it a little more transparent. That's probably good. So get out of this. And now I paste my free body diagram here. Oh no, I have this white background on here that uglifies the rest of my background here. First I want to center this though, so Format, and click over here, Align Center horizontally. If I want to align center vertically, I can do that as well. But I don't like this white background here, so there's a way of getting rid of that too. So I click on my picture, and I see my Format. I'm in Format. If I'm not in Format, then I need to click on Format and go over to Color and Set Transparent Color. And now I just click anywhere on the white background. Boom, it's gone. And notice it even puts the color in, like in the little oval part of the G as well. So there it is. That's how you can put something in Microsoft PowerPoint with a diagram and also get rid of the background as well. So if there's anything else, then you can maybe try to contact me and I can answer any other questions. A lot of this stuff you also could have done using the various tools in PowerPoint as well. For example, arrows like this, and in this case you can actually edit the arrows and change the shape, but I've done it both ways, and I've actually found it more tedious to do it this way than to do it in Paint. But the plus side of editing arrows in PowerPoint is one, you can actually edit them, whereas in Paint you often have to start over or something like that. But another thing is you do get higher resolution here. But I found that for most of the things that I do with math and science, it ends up working better for me just to use Microsoft Paint. So it's up to you though, because there are these other tools in PowerPoint that can also help with this. So again, if you have any questions, please let me know.